We talked quite a bit in Chapter 3 about factoring, and factoring is a fancy word for division, just finding out what smaller numbers can be broken out of a bigger number. Now we're going to do it with expressions, and we're going to sort of do it the same way we did before. We're looking for factors, we're looking for numbers that can evenly divide into both terms. So it's sort of like undoing distributive property. When I look at something like this, 4y plus 2, that makes me think something was handed out there earlier, like in a distributive way, and this is now the result. If I work backwards, though, if I take 4y plus 2 and I think about, what about these two terms here? What do they have in common? What can they both be divided by? Well, I know they can both be divided by 2. And if they can both be divided by 2, 4y divided by 2 is 2y's, and 2 divided by 2 is 1. So now I've got two groups of 2y plus 1. So the factored expression would look like this. Two groups of 2y plus 1, which is sort of the opposite of what we did with expanding. If we look in the next one, 3d plus 9, I'm going to look at 3d plus 9 and think, what can they both be factored by? What number can be divided out of both? Well, if both of them are divisible by 3, because 3d divided by 3 is a single d, and a 9 divided by 3 is a 3. So it's three groups of d plus 3. So the factored expression would look like this. Three groups of a d plus 3. The great thing with this is that you can always check your answer by using distributive property. If I go back to this one, 2 times 2y is 4y, and 2 times 1 is 2, and it matches. This one, 3 times d is 3d, plus 3 times 3 is 9, and it matches where I started. Let's try factoring these four expressions. Factor them completely, which means if they can continue to be factored after the first number you guess that goes into them, keep going, and then all those things that could go into it, let's say it's like a 2 and a 3 and another 2, all those can be multiplied to come up with the greatest common factor, just like when we did greatest common factor before. So let's try these four, see what you end up with. You can pause it here. Starting with the first one, 24g plus 8. I'm going to try to think, what can they all be divided by? Yeah, they can be divided by 2, I guess. That gives me 12g plus 4. And I guess those can be divided by 2 as well. That's 6g plus 2, and I think those can be divided as well. That gives me 3g plus 1. But now over here I've got this 2 times 2 times 2. Actually, 8 is what factors into this the most. So my answer should be 8 times 3g plus 1. What you have to remember is you have to keep dividing until there's literally nothing else that goes into both of them. If I look at the next one, 21b minus 7, they can both be divided by 7. That gives me 3b minus 1. I think that's it. 7 groups of 3b minus 1, so that's 7 times 3b minus 1. So I look at 45h plus 5. If I take 45h and 5, and I think what can divide into both of them, clearly 5 works. Gives me 9h plus 1, and I don't think I can do a whole lot of that. Not a whole lot else there. That's it. 5 groups of 9h plus 1, so that's 5 times 9h plus 1. And our last one, 54z minus 6. 54z minus 6. I think I could divide them by 2. That's 27z minus 3. And I think those can be divided by 3. That's 9z minus 1. Okay, so that's the smallest group I can make, but it's 6 groups of them. So it's 6 groups of 9z minus 1.